Here is a quick overview of what we will cover. We will cover how economists reward defending the paradigm, the limits to growth, the absurd calibration of economic climate models, the problem 1, imaginary numbers, the problem 3, linear extrapolation past tipping points, application, a real-world walkthrough, summary, how the lecture fits together. We will start with the foundations, build step by step, and end by tying the ideas together. Economists often get rewarded for sticking to traditional ideas, even when new evidence suggests otherwise. Put more directly, William Nordhaus received the Nobel Prize for his work on climate change, which involved critiquing earlier models like the limits to growth. For example, Nordhaus criticized the world dynamics model, claiming it lacked empirical data. What this example shows is that this shows how defending established economic paradigms can lead to recognition, even if the critiques are not entirely accurate. Understanding this dynamic helps us see why some economic theories may resist change, which is crucial in addressing climate issues effectively. Once that is clear, the next step is the limits to growth, because it develops the next piece of the same argument. The limits to growth is a study that predicted the potential collapse of civilization due to resource limits. Put more directly, published in 1972, it used system dynamics to model population, resources, and environmental impacts, arguing that exponential growth has limits. For example, the study ran scenarios predicting that civilization could collapse by the 21st century unless drastic actions were taken. What this example shows is that this demonstrates the critical idea that unchecked growth can lead to dire consequences for society and the environment. Understanding these limits is vital for developing sustainable economic policies and practices. Once that is clear, the next step is the absurd calibration of economic climate models, because it develops the next piece of the same argument. Economic climate models often rely on flawed assumptions and data that don't accurately reflect reality. Put more directly, William Nordhaus criticized the limits to growth study, claiming it lacked empirical data and replaced its methods with his own. For example, Nordhaus's work, which involved using the Ramsey growth model, dismissed the careful calibrations of the limits to growth model. What this example shows is that this highlights how shifting methodologies can lead to vastly different conclusions about climate impacts on the economy. Recognizing these flaws is crucial for developing more accurate models that can inform effective climate policies. Once that is clear, the next step is the problem 1, imaginary numbers, because it develops the next piece of the same argument. Some economic models use data that doesn't relate to climate change, leading to inaccurate conclusions. Put more directly, the enumerative method in economic models attempts to categorize national income by sectors sensitive to climate change. For example, models estimate that only about 3% of U.S. national output is produced in sectors highly sensitive to climate change. What this example shows is that this suggests that many sectors may not be directly impacted by climate change, which can mislead policymakers about the urgency of action. Understanding these limitations helps refine economic models for better climate policy formulation. Once that is clear, the next step is the problem 3, linear extrapolation past tipping points, because it develops the next piece of the same argument. We test the predictions of our theoretical growth model using, put more directly, cross-country data on per capita GDP growth and deviations of temperature and precipitation from their moving average historical norms over the past 55 years, 1960 to 2014. For example, cross-country data on per capita GDP growth and deviations of temperature and precipitation from their moving average historical norms over the past 55 years, 1960 to 2014. What this example shows is how the problem 3, linear extrapolation past tipping points, changes the behavior of the whole system once real feedback and interaction are present. This matters because once feedback loops dominate, you cannot explain the whole system by studying one piece in isolation. Once that is clear, we can pull the whole lecture together and see the full logic in one connected chain. Consider a simple hypothetical market facing a shock. A basic textbook model would usually isolate one variable and ask how the system returns to equilibrium. This lecture takes a different approach. It asks what happens when several forces move together, feed back on one another, and change the behavior of firms, households, or institutions over time. That is why the concepts in this lesson matter as a group. The application slide is where the theory becomes usable. It shows how the lecture helps explain a system that evolves instead of sitting still. This lecture builds in three moves. First, how economists reward defending the paradigm. The limits to growth define the problem and show why simple equilibrium thinking misses too much. Then, the absurd calibration of economic climate models explains the mechanism that actually drives change in the system. Finally, the problem 1, imaginary numbers, and the problem 3, linear extrapolation past tipping points, apply that logic to real competition and industry behavior. The full lesson is that once multiple variables interact, innovation matters, and firms respond dynamically. Economics has to explain process and feedback, rather than assume the system settles down by itself.